So you're joining us in Unit 1, Topic number 2, where we're going to talk about congruency. So you may have heard about congruency beforehand, but the definition that we'll use in our class is two figures are congruent if and only if they have the same shape and size, right? So the most important word here is the same, right? There's a very important symbol that we use when we talk about congruent. When we think about what's a symbol for the same in math, I think of the equal sign, right? So that's not what we're going to use exactly, but it's going to be an equal sign with a squiggle on the top. That's what it means to be congruent. So make sure you have this symbol very visible in your notes, okay? So something that's going to be very important in this class, and we will do almost every single day, is marking diagrams. So we mark in diagrams that figures are congruent using something called tick marks. And I'll explain what that means in a second. So tick marks, let's kind of explore that more in example number 1. So in example number 1, I've said, given the following congruent figures, so that we know that there's something congruent about these figures, mark the diagram appropriately. And in this case, appropriately, if we're talking about congruency, means tick marks. So looking at letter A says, given the measure of CV, we learned that last time, the measure of CV is 1.2, so that means that this segment right here, that's 1.2, right? And the measure of CL is also 1.2. Those are the same measure. So we know that those line segments, CV and CL, are congruent. So since I know they're congruent, what can I do? I can mark them with these little tick marks like this. Okay? Now what we also do is, we don't know anything about VL here, right? We don't know the length of VL, so we're not 100% sure if it's 1.2 as well. Normally we would leave this blank, but I want to just show you that if it has a different length, right, we actually are going to use a different number of tick marks. So I'm going to put 2 tick marks on VL, which means, okay, it's not the same as the other 2 segments in that triangle, okay? We'll talk more about that in some of the examples to come, but let's look at letter B, okay? Letter B says, given that the measure of, now we're talking about angles, right? The measure of angle PSL equals 38 degrees. And the measure of angle MTA is also 38 degrees. Okay? So a common mistake is to want to mark just like up on the sides, something like that. Okay? But notice we're talking about the angle, and remember from last time we said that the measure of the angle is actually between those 2 rays, the 2 arrows that it is. So we know that that measure is 38 and this measure is 38, so we know that they're congruent. So I'm going to put 1 tick mark, and you put like a little loop and then a tick mark through those, and that means that those are the same. Alright, let's move on to a congruent statement. Alright, so the definition of a congruent statement is, a congruent statement tells us that two geometric figures are congruent. It's as simple as that. So the first example down there is done for us on the screen. But let's look at the directions, the number 2. The following figures are congruent. Okay, so there's something in the picture that tells us that they're congruent. And let's write an appropriate congruent statement. Now our answer, every time you write a congruent statement, is going to look like this. You're going to have a congruent symbol, right? And you're going to say something is congruent to something else. Okay, and we have to write in what that something is. So looking at number 1, what I see in this picture is I see a whole line segment, right? And then I see a point that kind of like breaks up that line segment. It looks like almost in the middle, okay? But most importantly, what I see is I see these 2 tick marks here. And remember, tick marks mean that those segments or that geometric figure, they are congruent. They have the same measure right now. So I know that this length of WY is the same as this length YX. So I can write the congruent statement, WY is congruent to YX, and we have that right here. Okay? Let's do out an example all together. Alright, so if I'm looking at letter B, I want to write a congruent statement, so I'm going to say something is congruent to something else. Okay? And let's look at the picture. I see tick marks, that's what we're looking for, inside these angles right here, okay? So that means that we're going to have two angles that are being congruent to each other. So I'm going to put the little angle symbols there. What are those two angles? Looking at the first one, okay, I like to always say, take a dog for a walk. I'm going to start at point A, way up here, walk to B, walk to D. Right? That's the first angle that has a tick mark. So that's angle A, B, D. Okay? Now the second angle that has a tick mark is the lower half of it. Well, we could start at D, go to B, then go to C. So that is angle DBC. And there's my congruent statement. That reads that angle ABD is congruent to angle DBC. All right, we just have two more examples, and this is where some things get interesting. So looking at this has a geometric shape with 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. And this hexagon, remember, we're trying to write a congruent statement. So I know something is congruent to something else. And we have to use the tick marks to figure out what that is. So I see one tick mark here, and I see another tick mark down here. Okay? Think about what that tick mark is lying on. That's lying on a line segment. So what I know is I know that this tick mark's lying on YZ. So it's saying YZ is congruent to, well, this tick mark's lying on WV. So it's lying on, YZ is congruent to WV. Okay? Now let's look at letter D, because I don't see, when I'm looking at letter D, it has 1, 2, 3, 4, 5 sides. That's a pentagon, and I don't see any tick marks, but what I do see is I see little labels of the side lengths that we have there. And now they're not pure numbers, they are expressions, right? But we can still figure out what's equal, right? So the first thing that kind of screams out at me is that there's one side with 4x right up at top, MN, and there's another one down here, right? So if both of those line segments are 4x units long, they're the same measure. They're congruent. I'm actually going to put tick marks in the diagram. So I'm going to say this side is congruent to this side here, okay? And we can write a congruent statement. I can say MN, right, is congruent to RQ. But there's also another congruent statement, right? I see 2y and 2y as a measure on two different line segments, or two different sides of the pentagon. And so now when I'm looking at this, I'm thinking, can I do this? Can I put one tick mark there and there to show that those are equal? And the answer there is no, right? If I put one tick mark, what you're saying is you're saying that 4x and 2y, they're the same thing. But that's not the case in this problem. So what do we have to do? Remember, we're going to use a different number of tick marks to represent a different length. So we know that these two segments here are the same, and these two segments here are the same, but they're different from each other, right? The red and the orange are different. And so the congruent statement that we can now write is NP is congruent to PQ, like that. And notice over here we have a lonely 3x, right? It doesn't have a partner to be congruent to. You can leave it blank, or if you want to get technical, right, we could put 3 tick marks to show that it's different, okay? But that one doesn't matter. I think it is now a good time to stop, and maybe you can try homework number 1.2 about marking congruent figures, or do some practice in class. And we will see you tomorrow. Bye.